Welcome everyone! This is a tutorial on the concept of a breadth-first search in computer science. I'm Mr. Ranieri, and we will look at how a breadth-first search can be used to go through a tree or a graph. This is a tree, and a tree is a bunch of nodes where each node can have child nodes. For example, this node here, principal, has 3 child nodes, 1, 2, 3. And this node, Year 7 teacher, has 2 child nodes, Alice and Bob. Every node has exactly one parent. For example, the node Bob has one parent being the teacher, Year 7 teacher. Year 7 teacher has one parent, node being the principal. Of course, the root node, the node at the very top, doesn't have any parents because it's at the top. This is a tree, and a tree is a special kind of graph. Graphs are a little bit looser because in a graph, which is very, very similar to a tree, you might have cycles, loops that go back and forth. A tree is a special kind of graph. Breadth-first search is a great way of iterating through all of the nodes in a tree, so going through all of the things that are in this tree. The way that it works is we start with a queue. A queue is a bit like a to-do list. New items are added to the end of the list, and we pop items from the front of the list to process them. We also keep track of every item that we've seen. We will call this variable seen, and this is a set. A set is like a list, but it has no duplicates. The queue initially just contains the root node, and the seen set is initially empty. So let's have a look how it will work. I've got one item in the queue, which is principal. I will pop that off the queue, and we will process it now. To process it, I add it to the set of things that we've seen, put it in here, and we'll loop through its children, one at a time. It has 3 children, Year 7 teacher, Year 8 teacher, and Year 9 teacher. So for each of them, I'll push them to the end of the queue. Great, we've finished processing principal. Let's process the next thing. The next thing on my list is Year 7 teacher, so I will pop the first thing off my queue and we'll process that. To process it, I add it to the set of things that we've seen. We look at the children being Alice and Bob. We loop through the children, and for each child, we will push it onto the queue. Okay, we're done with Year 7 teacher. We can do the same thing for Year 8 teacher, add it to the set of things we've seen, go through the children one at a time, there's only one, push it onto the end of the list, the end of the queue, and we can do the same for the Year 9 teacher. Now I'll see that the next thing in the queue is Alice, so I'll pop that off the queue and we'll have a look at Alice. We'll add Alice to the set of things that we've seen, and oh, hang on, Alice has no children, so there's no work to do there, we're already done. Do the same for Bob, pop Charlie, process Charlie, and pop David. And now we're done. We've iterated through the entire tree using breadth-first search. I really like breadth-first search because it's so useful in so many computer science problems that come up. And you can actually use it to process things that aren't trees as well. For example, if there was a loop going from here to here, such that the parent of Year 9 teacher was principal and the parent of principal was Year 9 teacher, you can use it to go through a graph that contains cycles like that. And you can also use it to detect cycles like that and to, I don't know, let you know that they exist. Let's have a look at what we've just done as pseudocode that you can then implement in Python. So first we set queue to be a list containing just the root node. And we set seen to be an empty set. And now as long as the queue isn't empty, as long as there is anything in queue, we pop the first item from queue and store it in a variable. For example, a variable called current. We add the current item to the set called seen, that variable there. And then for each child of current, for each child of the current node, we first check if it's not in seen, because if it's already seen, there's no reason to add it to the end of the queue. We've already processed it. So we check to see, is this something that we haven't seen yet? Is this a node that is not in the set called seen? And if so, we add it to the end of the queue. You can also add any logic here that you might also want to do. Maybe, for example, you want to print the current node, or you want to save a list of all of the nodes. I hope this has been helpful. Let me know if you've got any questions. I'll be happy to help you out. Bye, everyone.